In this video, I will discuss a JEE Advanced PYQ from the topic thermal physics. It's based on adiabatic process and isothermal process. And in adiabatic process, we have this relation between the pressure of the gas and the volume as P into V raised to the power gamma is constant. Pressure can change, volume can change, but it will change in such a way that this product P into V raised to the power gamma is constant. Gamma is ratio of specific heats under constant pressure and constant volume. Specifically, the amount of heat required to raise the temperature by 1 degree Celsius. That can be done in two ways. One, when the pressure is constant, that is Cp, and one, when the volume is constant, that is Cv. So for a given gas, Cp and Cv is known. From that, you can find gamma. So once the gas is known, gamma is known. So the pressure and volume of the gas can be changed, satisfying this relation for an adiabatic process. And let us consider an ideal gas. For an ideal gas, we have this relation PV equal to nRT for an ideal gas. So we can eliminate pressure here. In terms of other things, pressure can be written as nRT by V. nRT by V. So using this thing here, we get T into V raised to the power gamma minus 1 is another constant. Once the amount of gas is fixed, the number of moles is fixed, so N is a constant for a given amount of gas, and R is a universal constant, gas constant. So N is constant, R is constant. So this constant divided by this one is the second constant. These two constants are different, but we have this relation, temperature into the volume raised to the power gamma minus 1 is also a constant. So this is also true for adiabatic process. For isothermal process, isothermal means temperature is same. So obviously temperature is constant. Again, we are considering ideal gas. So once the temperature is constant for a given amount of gas, PV is also constant. Because all these constants are different. So with these simple ideas, we can solve this JEE Advanced question. This is the question. You can read it. 1 mole of an ideal gas expands adiabatically from initial state TaV0 to final state TF 5V0. Another mole of same gas expands isothermally from a different initial state TbV0 to same final state TF 5V0. The ratio of specific heats at constant pressure and constant volume of this ideal gas is gamma. What is the ratio of Ta by Tb? You can pause and run this question. So first it says 1 mole of ideal gas expands adiabatically from initial state Ta V0 to final state TF V0. So adiabatic process means T into V raised to the power gamma minus 1 equal to constant. So this we can apply between these two states. Ta into V0 raised to the power gamma minus 1 equal to final state TF into phi V0 raised to the power gamma minus 1. So this should be satisfied. And isothermally, the state goes from Ta V0 to TF V0. So isothermal temperature is constant, so this temperature Tb should be same as Tf. So Tb equal to Tf. Divide these two. That will give me Ta by Tb, which is what I have to find out. into V naught raised to the power gamma minus 1 equal to TF will cancel. So phi V naught raised to the power gamma minus 1. So V naught will get cancelled. Actually, V naught will be raised to the power gamma minus 1. So TA by TB is phi into raised to the power gamma minus 1. So option is the correct answer. Option is the correct answer. So for adiabatic process, T to be raised to the power gamma minus 1 is constant. So that applying between the two states which is given in the question. So TA into V naught raised to the power gamma minus 1. Initial temperature is T naught, initial volume is V naught, and final temperature is TF, and final volume is phi V naught. So this is for adiabatic process. And the same gas of isothermal process, the temperature goes from TB to TF. So since isothermal, the temperature should be same. So TB and TF are same. So here itself we can put TF as TB and take this thing here. That will give it TA by TB as phi into phi raised to the power gamma minus 1. So option A is the correct answer. So here for adiabatic process, we have this basic relation. This can be proved. It's a basic thermodynamic concept. So for deriving P raised to the power gamma equal to constant for adiabatic process, first of thermodynamics we have Q, the heat supplied, is equal to change in internal energy delta U plus the work done P delta V. So this is basically energy conservation equation. The heat supplied has gone in increasing the thermal energy of the system plus some work is done. So for adiabatic process, the heat supplied to the system is 0. Or here it's a gas. There is no heat supplied or heat taken out. So Q, the heat transfer is 0. So only the exchange between the internal energy and the work done. And internal energy is given as NCV delta T, where C is the specific heat of the gas under constant volume, and P delta V. And we can get CV from these two relations. This is called Mayer's relation. Cp minus Cv is the gas constant R, and Cp by Cv is gamma. This is definition of gamma. So from these two, I can find Cv and Cp. So here I'll get Cv as Cp by gamma. So here instead of Cp, I can write Cp is Cv into gamma. So instead of Cp here, I can write gamma into Cv. So from this, I'll get Cv as R by gamma minus 1. So using this thing for Cv here, that is N into Cv is R by gamma minus 1 delta T. And also, this is an ideal gas. This is an ideal gas. So we have this relation P equal to nRT. So differentiate both the sides. P into delta V plus delta P into V equal to nR delta T. The variables are pressure, volume, and temperature. For a given amount of gas, the number of moles is fixed, and R is a universal gas constant. So I have to eliminate delta T, or I can eliminate nR delta T. nR delta T is here. The same thing I have here. So instead of nR delta T, I can write P delta V plus delta P into V. So this left side is 0. So P delta V, I have 1 here and one more. Sorry, here I have 1 and then by gamma minus 1. So nR delta T is P delta V. So if you put there, I'll get P delta V by gamma minus 1 and here one more P delta V. So that's plus 1. And then this second term, delta P into V by gamma minus 1. This is simple manipulation. We just have to put nRT delta T as this quantity. So we have two terms. One is P delta V and delta P into V. So P delta V and delta P into V. So this thing we can simplify. This thing, if we take it here, it will become gamma by gamma minus 1. And here is 1 by 1 gamma minus 1. So gamma minus 1, if it cancel, we'll get this one. So from this, we'll get delta V by V into gamma equal to minus delta V by P. So this we can integrate both the sides. So integral of dV by V is ln V and integral of dP by P is ln P. and there will be integration constant. That integration constant we can write as ln C. So this is V raised to the power gamma, and if we take it on the right side, it will become ln P plus ln V raised to the power gamma. That can be written as ln of P into V raised to the power gamma. That's equal to ln C. From this, I get P into V raised to the power gamma equal to C. So for adiabatic process, this relation is valid. P into V raised to the power gamma is constant.